Okay, hi everyone, welcome back to this video series on Windows Server 2016 using WFAS instead. The newer platform used for establishing IPsec connection rules is the Windows Firewall with advanced security. Go ahead, open that up. As you are already familiar with doing, once inside, navigate to the connection security rules section, which is listed immediately below inbound rules and outbound rules. Connection security rules is where you define IPsec connection rules. If you right click on connection security rules and choose new rule, you will then walk through a wizard which is similar to creating a firewall rule. Once inside the wizard, to create your new rule, you start to see that the options available to you are quite different from the ones shown when creating a new firewall rule. This is the platform from which you will establish IPsec connection security rules that define what the IPsec tunnels look like and on what machines or IP addresses they need to be active. Advanced threat analytics. In my opinion, one of the coolest security features to come out of Microsoft this past year is Advanced Threat Analytics, ATA. It's not a feature or function built into Windows Server operating system, not yet anyway, but it is a software that rides on top of Windows to produce some amazing functionality. Essentially, what ATA does is monitor all of your Active Directory traffic and warns you of danger of or unusual behavior in real time immediately as it is happening. The idea of ATA is pretty simple to understand and makes so much common sense that it's something we are all going to wonder why it took so long to put into place. The reason for that is because under the hood, the processing and learning that ATS is doing is very advanced. Yes, I said learning. This is the coolest part of ATA. What you do is set up port mirroring on your switches so that all of the packets moving in or out of your domain controllers get mirrored over to the first piece of the ATA puzzle, the collecting servers. These are called ATA gateways. The ATA gateways then send this traffic onward to a centralized ATA center. The center receives this data and starts to find patterns. If Betty uses a desktop computer called Betty PC and a laptop called Betty Tablet, Advanced Threat Analytics will see that pattern and associate her user account with those devices. It also watches her normal traffic pattern. Betty usually logs in around 8 AM and her traffic usually stops somewhere around 5 PM. She typically accesses a few file servers and a SharePoint server. After a week or so of collecting and monitoring data, ATA has a pretty good idea of Betty's MO. Now, one night something happens. ATA sees a bunch of password failures against Betty's account. That in itself might not be something to get too excited about, but then all of a sudden, Betty logs into a terminal server that she doesn't typically access. From there, her credentials are used to access a domain controller. Uh-oh, this clearly sounds like an attack to me. With the tools built into Active Directory that we currently have at our disposal, what do? Nothing really. We might see the password failures if we dig into the event logs, and based on what we could try poking around other servers' event logs in order to find out what that account was accessing. But we really wouldn't have any reason to suspect anything. This could be the beginning of a very large breach, and we would never see it. Thankfully, ATA knows better. The management interface for ATA is like a social media feed, updates almost in real time during events I laid out above. If we had been looking at the ATA media feed, we would have seen all of these items that I've pointed out happen as they happened, and it would be immediately obvious that someone compromised Betty's account and used it to gain access to a domain controller. There has never been a technology that watches Active Directory traffic so intensely, and there has certainly never been anything that learns patterns and behavioral diversions like this. It is truly an amazing technology. And I don't say that only because I happen to know the guys who built it, but since I do, I can tell you that they are brilliant, which is already pretty obvious since Microsoft scooped them up. At this point, ATA is still new enough that most of the IT community hasn't had any interaction with it, and I strongly encourage you to change that. It may save your bacon one day. The following is a screenshot of the ATA web interface, so you can get a visual on that social media style feed. This screenshot was taken from a Microsoft demo where they purposely stole the Kerberos ticket from a user and then utilized it on another computer in order to access some confidential files that only Demi Albus should have been able to access. While ATA did not stop this activity, it immediately, and I mean within seconds, alerted inside this feed to show the ticket attack. Lightweight gateway. If port mirroring data to the ATA gateway sounds too complicated or too involved for you, make sure to check out the new ATA Lightweight Gateway. This is an ATA gateway component that installs directly onto your domain controllers, so you don't have to make changes to your networking equipment. While this is a much easier approach to getting the data from your DCs into ATA, it does come with some drawbacks that I wanted to take a minute to point out. If your environment flows more than 10,000 packets per second from the domain controllers, then you should run a real ATA gateway with the large port mirroring setup. Typical domain controllers will be well under this number, but in large environments, it will be a consideration. There is a sizing tool available on the ATA website, which runs in your environment and captures these numbers on your DCs. You can also download here https://aka.ms ATA sizing tool. If you intended to pursue in having ATA is to be secure, then you should really go with the port mirrored gateway setup. One of the huge advantages of running ATA is that it is completely invisible to an attacker who might be inside your network because of the port mirroring configuration. On the other hand, if you install the lightweight gateway on your domain controllers, that installer will be obvious to the attacker and they could try to shut it down. General security best practices. Sometimes we need only to rely on ourselves and not necessarily functionality provided by the operating system. To secure our systems, there are many common sense approaches to administratorship. If this is a word that are easy to accomplish but are rarely being used in the field, the following are a few tips and tricks that I have learned over the years and I have helped companies implement. Hopefully you as the reader will have even more to add to the list as to what works well for you. But if nothing else, this section is intended to jog your thinking into finding creative ways which you can limit administrative capability and vulnerability within your network. Get rid of perpetual administrators. Do all of your IT staff have domain admin rights the day they are hired? Do any of your IT staff have access to the built-in domain administrator account password? Do you have regular users whose logins have administrative privileges on their own computers? You know where I'm going with these all terrible ideas. Unfortunately, the above was the status quo for many years in almost every network, and the trend continues today. I still regularly watch engineers use the administrator domain account for many tasks when we set up new servers. This means they not only have access to potentially the most important account in your network and are using it for daily tasks, but it also means that anything being set up with this user account is not actually accountable. What do I mean by that? When I set up a new server or make changes to an existing server using administrator and I end up causing some kind of big problem, nobody can prove that I did it. Using agnostic user accounts is a sure way to thwart responsibility in the event that something goes wrong. I'm not trying to imply that you are always on the lookout for who did what, but if I mess something up on an application server, which I don't normally administer, it would be nice if the guys trying to fix it could easily figure out that it was me and come ask me what I did so they can reverse it. There are many reasons that using the built-in administrator account should be off limits for all of us. To address the client side, do your users really need administrative rights on their computers? Really? I think you could probably find ways around it. Bringing regular users down to user or even power user rights on their systems can make a huge impact on the security of those computers. It gives viruses a much harder time installing themselves if the user needs to walk through a prompt asking for admin privs before they can proceed with that install. It also keeps all of your machines in a much more consistent behavioral pattern without new and unknown applications and settings being introduced by the user. Use distinct accounts for administrative access. This idea piggybacks off the last one and is something that I have started employing even on all of the home computers that I install for friends and family members. It really boils down to this: have two different user accounts, one with administrative access and one without. When you are logged in for daily tasks and make sure that you are logged in with your regular user account that does not have administrative privileges either on the local computer or on the domain. That way, if you attempt to install anything or if something attempts to install, you will be prompted by the user access control UAC box asking you to enter an administrative username and password before the installer is allowed to do anything. I can tell you that this works, and I have stopped a number of viruses on my own computer from installing themselves as I'm browsing around the internet trying to do research for one project or another. If I get a UAC prompt asking me for an admin password and I haven't even clicked on the installer file, I know it's something I don't want. Also, all I have to do is click on no and the installer will not get a hold on my computer. On the other hand, if it is something that I'm intending to install, then it is a minor inconvenience to simply enter the password of my administrative account and allow the installer to continue. Use a different computer to accomplish administrative tasks. If you want to progress even further on the idea of separate user accounts, you could make your computing experience even more secure by utilizing a separate computer altogether when accomplishing administrative level tasks. One computer for regular knowledge worker tasks and another computer for administration. This would certainly help to keep your administrative system secure, including the remote systems that it has access to. And while it does seem cumbersome to have two physical computers at your desk, remember that with most SKUs in Windows 10, we have the ability to run Hyper-V right on our desktop computers. I actually do exactly this with my own computer. I have my computer that is running Windows 10, and then inside that computer, I'm running a virtual machine via Hyper-V, from which I do all administrative tasks on the sensitive servers. This way, a compromise of the normal computer doesn't necessitate a compromise of the entire environment. Whether you choose to split up administrative access at the user account level or the computer level, remember this simple rule: never administer Active Directory from the same place that you browse Facebook. I think that pretty sums this one up. Never browse the internet from servers. Seems like a no-brainer, but everyone does it. We spend all day working on servers and very often have to reach out and check something from a web browser. Since Internet Explorer exists on Windows servers, sometimes it's just quicker and easier to check whatever it is that we need to check from the server console where we are working, rather than walk back over to our desks. Resist the temptation. It is so easy to pick up bad things from the internet, especially on servers, because if any machines on our network are running without antivirus protection, it is probably on the server side. The same is true for internet filters. We always make sure that the client traffic is flowing through our corporate proxy if we have one, but we don't always care or whether or not the server traffic is moving outward the same way. Don't even do it for websites you can trust. A man-in-the-middle attack or a compromise of the website itself can easily corrupt your server. It's much easier to rebuild a client computer than it is a server. Role-based access controls. The phrase role-based access control, RBAC, is not one that is limited to Microsoft environments. It also is not a particular technology that can be utilized inside Windows Server 2016, but rather it is an ideology that is all separating job roles and duties. When we think about separating our employees' job roles from an IT perspective, we traditionally think in terms of Active Directory groups. While adding user accounts to groups does solve many problems about splitting up levels of permissions and access, it can be complicated to grow in this mentality, and ultimately AD groups still empower administrators with full access to the groups themselves. RBAC technologies divide up roles at a different level, caring about more than permissions. RBAC focuses more on employee job descriptions than access restrictions. There are a number of different technologies that can take advantage of RBAC tools integrated into them, and there are even third-party RBAC solutions which ride on top of all your existing infrastructure, making it widely accessible across your entire organization and not restricted to working in the confines of a single domain or forest. Just enough administration. A great example of an RBAC technology that is included in Windows Server 2016 is just enough administration, JEA, which is part of PowerShell 5.0. JEA provides you with a way to grant special privileged access for people without needing to give them administrative rights. which would have been required to accomplish the same duties in the past. The necessity to add someone to the administrators group on a server so that they can do their job is quite common. But JEA is a first step away from that necessity. In our old way of thinking, it might be easy to think of JEA as doing something like allowing users to have administrative access within PowerShell, even when they don't have administrative access to the operating system itself. But it's even more powerful than that. The design of JEA is such that you can permit users to have access only to run particular PowerShell commands and CMDlets at an administrative level, leaving other commands that they do not need access to in the dark. In fact, if a user is working within the JEA context of PowerShell and they try to invoke a CMD-LAT, this is not part of their allowed CMD-lets. PowerShell pretends like it doesn't even recognize that CMD-let. It doesn't say, sorry, you can't do this. It just ignores your command. This definitely helps to keep prying fingers out of the cookie jar unless you want to let them in. Let's take it a step further. Maybe you are a DNS administrator and you might occasionally need to restart the DNS services. Since we are adopting the GEA or BAC mentality, you are going to have administrative rights on the operating system, but you will have JEA-based rights within PowerShell so that you can run the tools that you need in order to do your work. Restarting the DNS service requires access to use the restart service CMD-let, right? But doesn't that mean I will be able to restart any service on that server and could potentially do all sorts of things that I don't need to do? JEA is even powerful enough to deal with this scenario when setting up the level of access that the user needs to get. You can even dive into particular CMD-lets and divide up permissions. In our example, you could provide the user with access to the restart service CMD-let, but only give permissions to restart particular services like those pertaining to DNS. If the user tried to restart service on Win or M, they will be denied. Device Guard. A new Device Guard security mechanism that exists in Windows 10 and now Server 2016 is Device Guard. This is a technology that is all about limiting which applications are allowed to run and install on your systems. Effectively, you can have a whitelist of allowed applications, but even if you don't want to manually specify each application, you can do things like enforce that only applications which have a code signing certificate are allowed to run. Apps that are not trusted natively by Microsoft are not explicitly trusted by you, simply don't run, while there are other technologies that accomplish similar functionality already, like AppLocker. Device Guard is unique in that it manages both the user and kernel mode process. Even if an attacker gains access to the operating system of your server, if you have Device Guard policies in place, then you would be able to launch and run malicious software. Credential Guard, having some similarities to Device Guard. A new function called Credential Guard also makes use of virtualization-based security in order to keep information stored off in isolation so that only specific parts of the system can access it. Specifically with Credential Guard, we are talking about storing password hashes in Kerberos tickets. Prior to Windows 10 and Windows Server 2016, password hashes and tickets were stored on the hard drive of a machine in something called a local security policy, LSA. Those hashes were very easily stolen by using simple free tools available on the internet. This is exactly how attackers accomplish pass the hash and pass the ticket attacks by gaining access to a machine, sucking out the hashes or tickets by using a utility like K-list, and then attempting to use those tickets against other machines on the network with Credential Guard running on your systems. This is absolutely no longer possible. That sensitive information is now stored in a protected virtual hardware environment that is completely isolated from the operating system itself. Using a tool like K-list now shows you nothing and gains you nothing from which you can accomplish these age-old attacks. Summary: the number one agenda item for many CIOs this year is security. Security for your client machines, security for your networks, security for your cloud resources, and most importantly, security of your data. There is no single solution to secure your infrastructure. It requires many moving parts and many different technologies all working together in order to provide safety for your resources. The purpose of this chapter was to provide examples of security measures and technologies that can be utilized in anyone's environment, as well as to reprioritize the importance that security has in today's IT world. Concerns about privacy and security need to be discussed for any and every technology solution that we put into place. Too many times do I find new applications being implemented inside organizations without any regard to how secure that application platform is. Apps which transmit or store data unencrypted need to be modified or dumped. Protection of information is essential to the longevity of our business. When discussing security in Windows Server 2016, it is also critical to talk about a couple of completely different installation paths that you can take when implementing your servers. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.